Okay, so in 5b, we're talking about arc length and area of a sector. So you can have a look in your textbook, it does have these kind of images up and it does describe it, okay? If this is the radius, then the distance around here is the arc length, okay? Here we have some section, some sector of a circle, and the arc length is going to be that distance there, and the area of the sector is that area of the shaded region here. And so we've got a couple of formulas. I've scribbled them up here so that we can apply them in a sec. But basically for radians, arc length is this one, area is this one, and then for degrees, arc length is this one, area is this one. Okay, so we're just going to look at the problems, figure out which formula are we going to use, and then apply it. So I'll scroll down to the problems. So here's the two problems. Find the arc length and area of the following sectors. So here's our first sector here, right? It's a portion of a circle. The angle we're presented with is in degrees. So that means when we're finding the arc length and the area, we need to use the degrees formula. So we're using these ones. We'll start with this one. The length is equal to theta on 360. So that's the angle we're given divided by 360 times 2 pi r. Of course, 2 pi r is the formula for the circumference of a circle. And here we have a fraction of the circumference of a circle. So it's very intuitive, this formula here. So the arc length is equal to theta on 360 times 2 pi r. That's the formula. I'm going to substitute in the numbers. Theta is 100. The radius is 7. And then you just put all of that into your calculator and we'll round it. 100 on 360 times 2 times pi times 7. 35 on 9 pi. And this one we will round. We are going to round this one because it's not an angle. Remember I said before, leave it exactly. This one is not an angle, it's a length. And because it's a length, we want it to be stated to 3 significant figures. So we have 12.21, which is 12.2. And our unit is centimetres. Okay, so we all love a good bit of measurement. All right, all we're doing is taking the formula, substituting in the angle and the radius, and crunch it. Okay, let's do the area next. So the area of a sector in degrees is equal to theta on 360 times pi r squared. Again, pi r squared is the formula for the area of a circle, and we have a fraction of a circle. Just sub in the information and crunch it. Oops. Again, pops out in exact form, 245 on 18 pi. And we'll round it because it's a unit, right? It's a unit of measurement. It's an area, 42.76, which is 42.8 centimetres squared. Okay, so we found the arc length here. We found the area here, just using those formulas for degrees. No? Okay, we look at this one. We're presented with the angle in radians. 5 radians. We know it's radians because we've got C. C is the symbol for radians. Okay, so that means we're using these formulas here. Alright, so our arc length is equal to theta times the radius, which is equal to 5 times 3, 15. Okay, the arc length is 15. What's the unit? Inches. Alright, I copied it from an American website, obviously. And then for area, the area of this sector, half theta r squared. Half times 5 times 3 squared. So that's 9 times 5, 45, half of that, 22.5. inches squared. Okay, whenever we've got area, it's a unit squared, right? Okay, so look, all we're doing here, taking the shapes, putting the numbers into the formula. I think maybe the trickiest part is going to be whether do I use degrees or do I use radians? Look, okay, if it gives you in degrees, use degrees. If it gives you a C, that means it's in radians. If it's in terms of pi, it's in radians. So these two exercises, right, maybe here's a good point for me to say, like it's probably a waste of time doing every single question in question one because you're just repeating the same skill over and over and over again. It's just monotonous. All right. The point of the exercise is to grasp the concept and then move on. So I'm saying like probably all you really need to do from 5A is sum of question 1 and sum of question 3. That's touching on both skills, done. From 5B, question 1 and question 2. Again, that's touching on the skill of using the radian formula. All right. And then 5B's got lots of questions, and there is some problem solving a bit later on that you might want to have a look at if you want to challenge yourself. But be smart about it, like get these done, and then you can spend some time on your folio task. Okay? Particularly these two exercises, 5A and 5B, we don't want to waste too much time, just repeating some simple skill over and over. Any questions? All right, so I'm very happy if you've done those, then you can spend some time on your folio task in today's lesson.